So here's problem number 7. We're looking at the growth of bacteria. The growth of bacteria in a petri dish. Do these numbers represent exponential growth or decay? What do they represent? First thing I do is I compare this guy to this guy. So G of 1 over the guy before him, G of 0, which is equal to G of 1 is 2 over G of 0, that's 1, and that's equal to 2. Now we're going to compare the next two guys. Well, what two guys are that? We're going to compare this value to this value. Let's do that right now. G of 2 over G of 1. And what does that give us? 4 over 2, which is equal to 2. Well, what's the next thing we ought to do? Well, we'll compare this guy to this guy, which is G of 3 to G of 2. G of 3 to G of 2 is equal to what? 8 over 4, which is also equal to 2. I need some fighting room, so I'll move these guys up. They're all equal to 2 so far. We can remember that. And the next one and last one that I'm going to compare will be this guy. These two guys I'm going to compare now. I'm done with him. I'll compare the last two guys. That's G of 4 over G of 3. And that's equal to 16 over 8, which is also equal to 2. So what do we have here? A pattern. What are these things over here? Answer. They are a ratio. What are they? They are a ratio. They are a ratio of terms that are exactly 1 unit apart. Correct? They are a ratio of terms that are 1 unit apart. The ratio of terms that are 1 unit apart are the same and are greater than 1. This indicates exponential growth. Next problem, does this data represent exponential growth or decay? Growth or decay? Exponential growth or decay? Well, let's make ratios. G of 2 over G of, 1, 2, that should be 0. I'm fired. I admit it. I'm fired. G of 1 over G of 0. Oh my goodness. G of 1 is equal to 18. G of 0 is equal to 9. 18 over 9, that's equal to 2. I got that one. How about G of 2 over G of 1? That's 81 over 18. And, get out the calculator. 81 divided by 18 equals 4.5. All right. Not the same. 4.5. What about g of 3? This guy. G of 3 over g of 2. 100 over 81. What's that equal to? It equals 100 over 81. Uh-oh. That's equal to 1 point something. That's equal to 1.1. I know that. Let's get that guy up here. What was that again? 100 over 81. 100, whoops, clear that off. 100 divided by 81 equals 1.2. Ooh la la. 1.2. Doesn't look like any of these guys are the same. What about g of 4 over g of 3? Oh my goodness, what does that give us? That gives us 320 over 100. Uh-oh. That's 3.2. Oh my goodness, 3.2. None of these are the same. What does that mean? So what does this tell us? The values 2, 4.5, 1.2, and 3.2. Well, it tells us that the ratios of the successive values that are 1 unit apart, that is, are all different. Oh my goodness. They're all different. What does that make this? It makes this neither exponential growth or decay, nor decay. It is neither. It's not this guy, and it's not that guy. It is neither. Okay, on this, the last example, does this represent exponential growth or decay? Well, we find out. We say g of 1 over g of 0. And that equals what? 32 over 64. And that's equal to 1/2. What's the next one? Well, that's g of 2 over g of 1. And that's g of 2 is 16 over g of 1, 32. That's equal to 1/2. Oh, okay. How about g of 3 over g of 2? G of 3 over g of 2. What does that ratio equal? Well, that's equal to 8 over 16. And that's equal to 1/2. And finally, g of 4 over g of 3. And that's equal to 4 over 8. And that also is equal to 1/2. So all of our ratios that are 1 unit apart are the same. They're equal to 1/2. So all ratios 1 unit apart are equal to 1/2. What does that tell us? Well, this tells us that the function decreases as t increases. And of course, that means exponential decay. Okay, well that's the end of problems 7 through 9. So long now.